7.7 is about complex fractions. And a complex fraction is a fraction within a fraction. There are two types of problems that we're going to look at. Our first three problems are what I call type 1. Type 1 is a complex fraction that has a fraction over a fraction. One fraction over one fraction. It is complex. The fact that there's just one fraction on top and one fraction on bottom makes it what I have called type 1. And when we do type 1 problems and we're asked to simplify them, what I'm going to remember is that a fraction line means division. That's what type 1 is going to be like. So our instructions say to simplify. So I will rewrite the problem so it's large enough for those of you in class to see it. And it is 16 over 3x all over 8 over 6x. I'm going to treat these as division problems. So this is 16 over 3x divided by 8 over 6x. And now it should be very familiar. It's a 7.2 question. What do we do for division? Keep, change, flip. So keep 16 over 3x, change to multiplication, and flip this 6x over 8. Now look at it and tell me if you see anything that you can reduce. 8 goes into itself once, 8 goes into 16 two times. 3 goes into itself once, 3 goes into 6 two times. The x's, single x, single x. So what am I left with? Numerator, 2 times 2 is 4. Denominator, 1 times 1 is 1. You would not write 4 over 1, just 4. That's type 1 of the complex fractions. The instructions will tell you to simplify. The process for simplifying is to rewrite it as a division problem. Okay, let's look at number 2. Problem number 2 looks like, if I write it larger, it is 4 over x minus 2 all over x minus 2. I notice right away that it's a complex fraction. My instructions tell me to, I'm so sorry. My instructions tell me to simplify it. And how do I simplify a type 1 problem? Write it as division. So this will be 4 over x minus 2 divided by x over x minus 2. So keep, change, flip, keep 4 over x minus 2, change to multiplication, invert the second fraction. And now check to see if there's anything you can reduce. Yes? Do you see the x minus 2's are common factors? Anything else? I don't think so. My final answer will be 4 over x. These type 1 problems are very easy to do. Let's look at the last one of those. Number 3. Just more of the same. I have x plus 4 over 5 all over 4x minus 1 over 15. Do you see it as a type 1 problem? Single fraction over single fraction. So I'll keep x plus 4 over 5 divided by 4x minus 1 over 15. That turns into x plus 4 over 5 times, whoops, did it again, 15 over 4x minus 1. Can I factor x plus 4? No. Can I factor 4x minus 1? No. Do I have common factors with the 5 and the 15? Yes. 5 goes in there once, 5 goes in there 3 times, and you are more than welcome to leave your answer as 3 times x plus 4 over 4x minus 1. And you don't need to distribute that.
You don't have distributed 4x, the denominator 4x minus 1 at the top of 15. It's at 15 over 4x over 1.
Right.
You don't have to distribute that? Leave
No.
it as it is?
Leave it as it is. Okay. Now, if you put as your numerator answer 3x plus 12, that would be fine. You just don't need to. Does anybody have a question on method 1? You know when to use it and you know how to use it. Okay. Method 2, let me write, this is problem number 4. Let me call it type 2. That's what I was calling them. Type 2 has either a sum or a difference of fractions in the top, or maybe in the bottom, or maybe both. But there's more than just a single fraction over a single fraction. This particular example has a fraction plus a fraction over a fraction minus a fraction. It doesn't have to be quite that complicated, but if you have either the sum or the difference of terms in the top or the bottom, then you can't do method 1. Okay, so let me recopy this for the class. I have 3 over x plus 4 over x squared all over 9 over x squared minus 16 over x. Can you see it as a more complicated expression than my type 1 problems? Because I don't just have one fraction on the top and the bottom. All right. In this type of problem, you can't do keep, change, flip. Because how would you flip something that's a sum or difference? Well, you'd have to get a common denominator and add them together or subtract them, and it would be a huge mess. And you don't have to. What we're going to do, I want to do things that only change the look of this, but don't change its value. All right. What I'm going to do is multiply it by the number 1. Do you agree that the number 1 can take a lot of different forms? 5 over 5, 9 over 9, x squared over x squared. There's a lot of ways to write the number 1. What you're going to do, I hope, is find the least common denominator for all of the denominators that you see. What is the LCD? It is? I need an x squared. I need the high power. Remember, I need something that they will all go into, x squared. Do you agree that x squared over x squared is equal to 1? So if I multiply the entire top by x squared, the first fraction will get multiplied, and then the second fraction will get multiplied. If I multiply the bottom, the first fraction will get multiplied, and the second will. So what I'm going to do is write down the x squared beside that one, beside the second factor, the second term, and beside both in the bottom. Whatever the least common denominator is, multiply it times each term of the top and each term of the bottom. because what you've really done is multiply by the number 1, so we haven't changed anything. All right, can I do some reducing? Let's look at just this piece. Can you reduce that? Do you agree that x divides out with one of those x's, leaving an x? And so for the very first position, I have x times 3, which is 3x. I look at the second one, and I reduce. X squared divides out with x squared, and I'm left with plus 4. Remember, my instructions told me to simplify. Does this look like it's getting simpler? I think it does. All right, first term of the bottom, the x squareds divide out. That leaves me with 9 plus sign. In the last term, x goes in there once, x goes in there an x times. So that leaves me with, need to change that sign, minus 16x. Can you factor the numerator? No. Can you factor the denominator? Almost, but almost doesn't count. If this had been an x squared, then you could have. It would have been the difference of squares, but it's not. So I'm done. We simplified this very complex looking expression by multiplying top and bottom every term by the LCD. That's what we're going to do in all of these more complicated complex fractions. Are we okay on this one? Okay, let's look at number 5. The original problem in number 5 is to simplify 2 plus 2/9 over 2 plus 4/9. Do you see this as what I referred to as a type 2 problem? Because it has the sum of terms in the top and the bottom. Our method for a type 2 problem is to look at all the denominators, which is just a 9 and a 9, and please tell me what the LCD will be. It'll be 9. It's the number that they will both go into. How many little blue 9s am I going to write down? 4. I'm going to multiply this by 9, this by 9, this by 9, and this by 9. Why did the 2 not affect the LCD? It's not a denominator. It's 2 over 1.
So it would be 2 over 9.
No, it would not be 2 over 9. It's 2 over 1. And so if you have a 1, a 9, a 1, and a 9, the common denominator is 9. Now when I multiply this, these are both tops, I simply get 18. Plus, in the second multiplication, the 9s divide out, and I get 2. There's no variables in this problem. Over, again, 9 times 2 is still 18, plus, the 9s divide out, and I get 4. That gives me a numerator of 20 and a denominator of 22. Final question, can I reduce that? Yes. 2 goes into the top 10 times, 2 goes into the bottom 11 times. This very complicated looking expression that I started with, right, well, you can hardly see it anymore. 2 plus 2/9 over 2 plus 4/9 is equal to 10 over 11. Method 2, find the LCD, multiply everything by it. That will cause your little denominators to divide out. Let's look at 6. Copying the problem over, I have 1 over x plus 2 over x squared all over whoops, x plus 8 over x squared. All right, I need to get, this is, I hope, obviously, a type 2 problem. And I have these denominators. What will the common denominator be? X squared. The LCD is x squared. So I'm going to multiply x squared times 1 over x squared times 2 over x squared times x, and x squared times 8 over x squared. Would you take a minute to reduce each of those 4 products if reducing can take place? What happens in the first little group? That x divides out with one of those x's, leaving you with x times 1, which is x. In the second group, the x squareds completely divide out, and it leaves you with plus 2 over, there's nothing to divide out here, that's x to the third. You want to be careful, you're used to dividing out, but this isn't a denominator. It's just x squared times x. Oh, there must have been a lot of erasing going on. There were comments. Now, look at the difference between what's up here where it was 1 over x and this one where it was x over 1. There was nothing to divide out. So that's x to the third. And then in the last group, denominator, x squared, those cancel out, and I get 8. Yes?
If there would have been an x at the bottom to the top, we would have been able to...
Yes, yes. So if there is no denominator, then no dividing out or canceling takes place, just a product. All right, can you factor the numerator? X plus 2. No, that's just x plus 2. Can you factor the denominator? Yes, it's been a few days, but that's the sum of 2 cubes. You don't get to put your factoring on the back burner and forget about it. It will burn. All right. The cube root of x cubed is x. Keep the sign. The cube root of 8 is 2. Then you square the first for x squared. Change the sign. Product 2x. Square the last one, plus 4. Hopefully, you see the common factor of x plus 2, which leaves you with what? I have x squared minus 2x plus 4. Make sure it's left in the denominator. And what's in the numerator? A 1. Because when I divided those out, even if I didn't write it, x plus 2 goes in there once, x plus 2 goes in there once. We don't write denominators of 1, but we have to write numerators of 1. Okay, so this was a really good problem. We did our method 2 or type 2, simplifying it, but what we got needed to be reduced by factoring. Okay, let's do one more of the type 2 problems. This is number 7, and it is 4 minus x over y over x squared over y squared minus 16. Can you see it as type 2? There's more than just one fraction on top and one fraction on bottom. So I need to know the LCD. It is y squared, so I'm writing that off on the side. your denominators are y and y squared, so the common denominator is y squared. So I'm going to multiply y squared times each one of those terms. What will I get as the first product? Okay, 4y squared. No dividing out. Second product, this y divides out with one of those y's, leaving a y, so that is xy, over, next one, the y squareds cancel out, and I have x squared. The last one, minus 16y squared. Now, after you've done the simplifying, you've done that part, now you've simplified the complex fraction aspect of it. Can you simplify it, the reducing aspect of it? Well, do you think you can factor the top? Common factor of y? Y times 4y minus x. Do you think you can factor the bottom? Yes. It's the difference of two squares, isn't it? So it will be x plus 4y and x minus 4y. There are not any identical factors, but do you see anything that we need to talk about? Yes, we see that this factor and this factor are opposites. They are complete opposites, 4y minus x and x minus 4y. We can divide out opposites, but what do we have to leave behind? A negative. A negative somewhere. So what I'm going to choose to do is leave the negative right there. That means the way I'd like to write the answer is negative y over x plus 4y. But I noticed in the answer sheet that the author of my math lab chose to put the negative sign, out in front. And it doesn't matter. Either position is fine, and math lab shouldn't care. I did this one, but it doesn't matter because this is okay too. Yes. Uh-huh. Yes.
Why wouldn't you put a y under the x and be canceled?
Okay, if I just take this little piece right here, and I'm going to go over here and blow it up. I have x over y times, and then I had this y squared sitting here. What I didn't have was that it was over 1. It was, though. And so now that y knocks out one of those, but there's only a 1 left on the bottom. Okay, so make that go away. Okay, are y'all okay on 7.7? The whole lesson was complex fractions. There were two kinds. The first kind had just a fraction over a fraction, and we changed it to division and did keep, change, flip. Then we looked at the kind that had more than one term on the top or the bottom, and we could no longer do keep, change, flip. We used the method of finding the LCD, and I'll just even write that, multiply all by LCD. And I had that written on problem number 4. So I did LCD, 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 LCD. Okay, then I will stop 7.7 and then we'll talk about reviewing for the test.